right? Time to synthesize, time to put things together, right? We've been discussing a lot of stuff about periodic trends. We talked about what they are. We talked about how they go side to side, how they go up and down, you know, periods and groups. Now let's see just the overall periodic table, right? The synthesis. That's sexy stuff right there. Synthesis, yeah, okay. The periodic trends in atomic radius, electronegativity, and ionization energy, those are my three boys, across a period. I mean, they could be girls too. That's okay. Across a period and down a group can be used together with the periodic table. In the upper right corner, atoms have very few electron shells and a relatively high number of protons. So relative for the shells, right? They don't actually have that many protons. It's just relative. This makes them have a high electronegativity, high ionization energy, and low atomic radius. So up here, this is high electronegativity and ionization energy, and it's a low atomic radius. Okay. In the bottom left corner, atoms have a lot of electron shells and relatively few protons. Again, relative, right, for the number of shells. These properties lead elements toward the bottom to have, man, it did it again. Well, it should say they should have a large electronegativity and ionization energy and a small atomic radius. So I'm going to put that here as well. So high, oh, not small atomic radius, whoops. Should be a high atomic radius. So a high atomic radius, they're really big, right? They have lots of shells, but a low electronegativity. Because the electrons are so far away, they're easy to take away. So low ionization energy too, because they're easy to take away. So basically, as you go from here to the top right, you are increasing in electronegativity and you're increasing in ionization energy, right? So this is increasing in electronegativity and ionization energy. Let's make that one, that can be blue. But then if you want to have, if you want to increase the atomic radius, you've got to go the other way, right? From here down to here, right? So that is going to increase the atomic radius if you go the other way. You know, you can use multiple colors on your text. Just saying. Why not make it fabulous? Okay, so I've got this kind of synthesized. So anything down here is going to have high atomic radius. Anything up here is going to be low. Low electronegativity down here, high up here. So, you know, if I have this compared to this, I can use that pattern. I can put the two together. I can do that. Okay, let's go a couple pages to learn about ions and ionic radius. I already remember ions are kind of like atoms, but I remember something with electrons. That's all I remember. An atom is technically defined as a neutral particle. Neutral means no charge. Right? Remember my awesome bartender joke? You don't? Go watch all the videos again. Come on. When an atom gains a positive or negative charge, it becomes an ion. Okay, so atom equals neutral, ion equal charged. It's a charged atom, basically. Atoms consist of protons, neutrons, and electrons, right? Protons and neutrons in the nucleus, electrons are in the shells. The neutrons do not affect the charge of the ion, right? Because neutrons, they have no charge. Protons contribute +1 positive charge for each proton. Electrons contribute -1 negative charge. -1 negative charge. Well, they just contribute a -1 charge for each electron. Neutral atoms will have the same amount of positive and negative charges. They'll have the same number of electrons and protons. So that's what this says. Atoms neutral. So you've got 6 positive, you've got 6 negatives, they cancel out. If it's negatively charged, so this one has 5 positive, 6 negative, so it's got 1 more negative, and so it becomes negative overall. This one says more protons than electrons for positive. So here we have 6 protons, 5 electrons. So we've got more positives than negative. It's positive overall. Makes sense. Alright, so I got ions, positive, negative, electrons, blah, blah, blah. Okay. When an ion is formed, the size of the atom, okay, that's radius, changes. Atoms that gain electrons form negative ions and become larger. These negative ions are called anions. I'm looking down here, I see anions. So these anions get larger. Alright, okay, it's like they eat some McDonald's, they get bigger. Yep, that's how it works, people. Okay, yeah. That makes sense, they're gaining electrons. It says protons can no longer hold on to the electrons very well, and the electrons get farther away from the nucleus. Yeah, okay. I mean, if you have like 5 dogs that you're trying to take care of, you know, they're gonna escape. You know, they're gonna get farther away, I guess. Okay, atomic radius increases. But really, it wouldn't be atomic anymore, right? It would be ionic radius. Atoms that lose electrons, okay, those are positive. They become positive, right? Because they're getting rid of negative, because they're losing a negative charge. After losing an electron, the atoms have more positive charges, those are the protons, than negative charges. The overall charge becomes positive. That's what we just saw on the other, at the top. These ions are called cations. Hey, quick way to remember this. Cations, the T looks like a plus for positive. Anions, they've got an N for negative, right? So N for negative. Good way to remember it. Okay, so positive ions, cations, they're getting bigger. Or no, they're getting smaller. They're getting smaller, right? Cations get smaller because they're losing electrons. Since they have more protons than electrons, the electrons get pulled in closer and the atomic radius decreases. Makes sense. So what do you think would happen if I had like magnesium and it lost 2 electrons? What do you think would happen? You draw what you think that would look like. I'll see you in class.